Hello, I'm Trevor. I run the Chem 2 AEWs here on campus. And today I'll be going over a gas loss question that incorporates mass and molar mass. For this problem, we're going to use a slightly different formulation of the universal gas law. We're going to start out with PV equals nRT. And I'm going to simply rearrange by dividing both sides by nRT. You get PV over nRT is equal to 1. And then I'm going to multiply both sides by mass. So MPV over nRT is equal to the mass, right? And the important thing to notice here is M over N, mass divided by moles, is molar mass. So I can have cap M, the molar mass, times the pressure, times the volume, divided by the universal gas constant times the absolute temperature is equal to the mass. So this is still just the universal gas law. All I've done is rearrange and multiply it by mass on both sides. If this is confusing to you for some reason, you can always, if you need to solve for a mass, solve for moles, solve for N instead, and then simply use the molar mass and the mass to figure out the rest of the answer. But I think this is a pretty straightforward way of condensing your equation down to one step. So for this problem, we're asked to consider a big gas cylinder of nitrogen. You may have seen these around campus, around in various labs. Big, tall metal cylinders, very heavy, full of compressed gas. So for this question, we're told that we have one of these cylinders, 3,000 psi gauge pressure, 50 liters in volume, and the room is at 20 C. And we want to know what the mass of nitrogen in the cylinder is. So first thing to do, run from this equation, start throwing down some numbers and some units. Units are very important in questions like these. Molar mass, 28 grams per mole, that's nitrogen. Multiply that by 3,000 psi. But is it just 3,000 psi? 3,000 psi is the gauge pressure. So that's the difference between the tank and the atmosphere. So the absolute pressure in the tank requires us to multiply or add on the pressure of the atmosphere as well, which is 14.7 psi. So that's in psi. I'm going to throw in a conversion here because I'm going to use R in metric units and SI units because they're easier to work with. So there are 6.89 kilopascals per psi. And the last thing I'm going to multiply it by is the volume, which is 50 liters. Big fraction bar. Next, we have the universal gas constant. I'm going to use 8.3144. That's in joules per mole Kelvin, or liter kilopascals per mole Kelvin. And finally, the temperature, which is 20 degrees C. Convert that to Kelvin. Get 293 Kelvin. So what units do we have? We have psi canceling out with psi, kilopascals canceling out with kilopascals, liters canceling out with liters, Kelvin canceling out with Kelvin, moles canceling out with moles, so it looks like our final answer is going to be in grams. And if you work this out, you should get 11.95 kilograms. Notice the unit change, grams to kilograms, just by a factor of 1,000. So here, we took the universal gas law and incorporated mass and molar mass to get one simple equation that we can use to deal with questions like this, whenever you're asked how much does an ideal gas weigh. For more information, you can come to my workshops, 6 to 7 p.m. on Wednesdays in Brown West 210, or my office hours from 2 to 4 p.m. Mondays and Wednesdays in Casa.